Good morning, student. Good morning to all. I am audible and my screen also visible. Please confirm anyone. Guys, anyone please confirm that my screen is visible and I am audible clearly?
Yes, sir. Yes.
Okay, thank you. Train quarter. Hello. Okay, let's start. Good morning to all.
Morning, sir. Morning, sir. Morning, sir.
Good morning, sir.
Good morning, sir.
Okay, so I have already shared the exam code in your group. So please, within a time period, the time period basically starting from 9:20 to 10:30. So within this period, please give your exam. So that is very important. We just compare with that attendance with the class attendance. Those people are present in the class. I will consider both. So please be very careful. You give your exam. Please give your exam. Okay. So let's start. So in the last class, we have discussed with the frequency domain and DFT, application of DFT, discrete Fourier transform. So today I will start with from the Twiddle factor. So I request everyone, please stay with your pen and paper. Please stay with your pen and paper, and also you stay with your scientific calculator. So here we perform, here we practice some problem also. So please stay with pen, paper, and the calculator. Scientific calculator is required. So let's start with the discrete Fourier transform. So before that, I just recap whatever we discussed in the last class. So frequency domain, why we prefer that will already discuss. The frequency analysis of the discrete time signal is usually most conveniently performed on digital signal processing. For designing prospect, general purpose digital computer or specially designed digital hardware is possible, and where we actually apply the DFT in spectrum analysis, FFT filter bank, array of bandpass filter. Later on, that part we'll discuss by Otonu sir most probably. So that FFT filter bank are depend on the DFT calculation. Then also the calculation involved with the data compressions, solving partial differential equation. We can see over the class. Polynomial multiplication also done over here. Multiplication of larger integer. That time we also use DFT. And obviously the last, not the least, that is the convolution. So you are familiar with linear convolution, how to solve a problem using the linear convolution. So here you can see the another type of convolution method, that convolution method called circular convolution. You can see here also. These are the application of the DFT. So anyone please respond that, do you remember about the linear convolution? Anyone? So can you perform, suppose x1 equals to 1, 2, 3, 4 and x2 equals to 1, 1, impulse response, if we impulse or step response if we consider. So anyone, can you perform that the linear convolution? That means the finding the value of x3. Anyone please respond? Anyone perform this one? Anyone please respond? Anyone? Anyone please respond? Anyone perform the linear convolution? So lot of students, they are waiting. Why you are not joining at class at 9, in between 9:20 to 30. So from next day onwards, after 9:32, I will not allow anyone. I will not allow anyone. So please, student, please attend. If you have any class, please attend my class at least before 5 minutes. Please join before 5 minutes. So from next day onwards, I will not consider anyone. I will not consider anyone. So anyone, please perform. Suppose x1 is 1, 2, 3, 4, and x2 is 1, 1, 1. You just perform linear convolution. Anyone? Shabanno, unmute yourself.
Yes, sir.
Yeah, please tell me. You remember how to perform the linear convolution?
Yes, sir.
In signal system, most probably this part already discussed. So here, two methods are there for linear convolution. I'm not discussing detail of the linear convolution. This is not my my part. It's not related with my syllabus also. Whatever I covered here. So two methods are there. One is graphical method. Another is add multiplication method. Here I just show you the add multiplication method. This is very easy. So let's see. Let's start with using two sequence. Whether x1 is 1, 2, 3, 4, x2 is 1, 1, 1. So here we consider 1, 2, 3, 4, and here we consider 1, 1, 1. And how to perform this problem? So let's see. This is 1, 2, 3, 4. 1, 2, 3, 4. We just multiply with this 1, 1, 1 with the 1, 2, 3, 4. First we multiply 1, 2, 3, 4. So now we just add the thing according to the. So here only 1 is present. So x3 will be 1, comma. We add with 1 plus 2, that is 3. Then next result is 3 plus 2 plus 1, that is 6. Then 3 plus 4 plus 2, 9. Then 4 plus 3, 7. And last one is 4. So this is basically the linear convolution answer. This is basically linear convolution answer. And another thing is that, what about the length of the output? If suppose the x1 length is, what about the x1 length? Anyone please response?
4.
4, good. And what about the x2 length?
3.
So what we have found, x3, that means the output length is basically 4 plus 3 minus 1, that is 6. So the formula is length of x3 is length of x1 plus length of x2 minus 1. This is length of x3. So according to the after the calculation, we can see here this is 6, and you can see here 1, 3, 6, 9, 7, 4. The length of the x3 also we getting, that is 6. So this is the method of linear convolution. Please, you take any example and you can perform yourself that linear convolution part. That linear convolution, there is a relation between linear and circular convolution. So that's the reason here today I just show you how to perform the linear convolution. Anyone having any doubt? If you have doubt, I can show you another example. If you have doubt, I can show you another example. Is that clear to all? Please respond. So can I solve another problem?
Yes.
Okay, I can solve it another problem. So I just rough here. So anyone please give some anyone give some sequence, give some sequence name.
5, 3, 4, 6, 7,
5, 3,
4,
7.
6, 7. Yes.
Okay. What about the x2? Anyone?
3, 5, 4.
3, 5, 4. Yes or no?
Yes.
Okay. Let's see. So I request you, you already know how to solve it. So you first try yourself in your pen and paper, using pen and paper. You solve it first. Individually, if possible, you can send me a WhatsApp. You take a picture and send me a WhatsApp. Then I will show you how to solve this problem. First, you solve it yourself. Anirban, please unmute yourself, Anirban. Anirban, please unmute yourself. Anirban, late কেন এত?
আমি আগে জয়েন করেছিলাম, ডিনাই করে দিলেন।
কটার সময় জয়েন করেছিলে বাবা?
4:33
কেন? ক্লাস টাইমিংটা যদি মাথায় না থাকে তাহলে কিন্তু প্রবলেম, আমি পরিষ্কার বলে দিচ্ছি। 5 মিনিট আগে ঢোকার চেষ্টা করবে। নেক্সট ডে অনওয়ার্ডস আমি কিন্তু আর কাউকে অ্যালাউ করব না। Okay, so please try yourself first, then I'll solve it.
স্যার
সাবর্ণ, তাই তো?
সৌভিক স্যার।
হ্যাঁ সৌভিক বল।
স্যার 15:34:47
পরে 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 আমি শুনবো, এখন নয়। এখন নয়, আগে সলভ করো, করে রাখো, আমাকে হোয়াটসঅ্যাপ করো।
আমি পাঠাবো।
কে পাঠিয়েছিস?
স্যার আমি সাবর্ণ।
লাবণ্য হয়নি।
স্যার আমি পাঠালাম।
দেখছি। ইয়েস, একদম ঠিক আছে। এক্সাম্পলটা কে বলেছিলিস রে তখন?
আমি স্যার।
আমিটা কে? আমিটা কে?
সাবর্ণ।
সাবর্ণ। মাথাটা গরম হয়ে যাচ্ছে, কত বড় অঙ্ক দিয়েছিস, সবার পক্ষে সম্ভব? নিজেই ভুল করে বসেছিস।
স্যার এবার বুঝতে পেরেছি ভুলটা আমি নিজে করছি, আরেকবার একটা।
দ্যাট ইজ দ্য রিজন, মানে আমি কেন বললাম সবাইকে করতে, দ্যাট ইজ দ্য রিজন। সো let's see. So we have lot of discussion today. So this is 3 into 5 is 15, 9, 12, 21. Next one is 25, 15, 20, 35. Yeah, 20, 12, 16, 28. We just make the cross. So now let's see, the x3 is basically, first one is only 15. Someone is saying to me, who is that? Response? Yes, good. Good. So this is 15. Then 25 plus 9, that is 34. Then 20 plus 15 plus 12, that is 47. Then 12 plus 20 plus 21. This is 53. 16 plus 35. That part is basically 51. Good. Then 20 is the only data is here present, that is 28. Is that clear, guys? Now you can solve any circular convolution problem. Yes or no? Please respond.
Yes sir.
Good.
Yes sir.
Thank you. So let's see. So we also discussed in that discrete Fourier transform, that discrete Fourier transform is came from the DTFT. So hopefully you know that DTFT. In the last class I also discussed that. You please go through it. You are just, you can consider any books which are related with the signal system or DSP. You can consider any books. Just understand what about the DTFT, discrete time Fourier transform. So in discrete time Fourier transform, when we are calculating that time, we are actually not focused on the length. We are calculating for the infinite duration of length, where for DFT case, we are considering a finite duration of sequence length, which is L. And after the Fourier transform, we get this value, and then we discretize, you know, four kind of signal you are already comfortable. Time domain, frequency domain. Time domain having two separate type of signal is there. One is the continuous, another is the discrete. For frequency domain also, one is the continuous, another is the discrete type. So discrete Fourier transform, when we are performed, that time the main sequence is basically time domain discrete type signal to frequency domain discrete type signal. So that's why what we are doing, in place of omega, we consider, we sampled of 2 pi k by n, and basis on that we get that the formula of DFT. We get the formula of DFT. The interesting part, using the DFT, we obviously require, here I am showing you the time domain sample to frequency domain. Both, in both cases, both are the discrete type signal. Now, what about the next part? When we are considering DFT sequence, that means this is the definition. When we are considering DFT, we also know about the recovery of DFT samples or sequence. How to recover? We are doing some procedure which called basically inverse discrete Fourier transform or IDFT. So using IDFT, the difference, when we are considering IDFT, the difference of we actually getting the time domain signal from the frequency domain, and the little bit changes is there in the compared to the DFT formula. We are considering xn small n equals to 1 by capital N. This is the reverse DFT formula we call summation. In previously we are considering n equals to 0 to n minus 1. Now we are considering k, because the frequency domain signal are depend on the k. So k equals to 0 to n minus 1, capital Xk e to the power. In place of minus, here we are considering plus j2 pi n into k. Previously k into n we are considering by n. This is the reverse or IDFT formula. So it's called IDFT. Now here you can see the DFT and IDFT. Now the question is that, in this formula, in this whole the formula, if we consider in the both cases, two separate parts are there. Anyone guess? Two separate parts are there. One part we are considering xn, another is the e to the power minus j or plus j 2 pi k n by n. So anyone guess what about the term?
The amplitude is the xn part and the e to the power that part is the phase.
This part is called
Amplitude.
amplitude. Are you sure, Rita? This part you are right. This part you are right. This is phase. Good. What about this part? Anyone try? Anyone try? Just guess.
Magnitude, not amplitude.
Yeah, magnitude. So same case for here also consider. So let's see in the next part. So here you can see xn, capital Xk also, both are the magnitude, and this part we are considering as a phase. Clear? Now we are talking about the phase part. What about the phase part? E to the power minus j 2 pi k n by n. We know already this part is phase. Now what about the e to the power j 2 pi nk by n? What the meaning of that in detail? So basis on that, we can modify some formula. So the basic thing, 2 pi by n. Just remember 2 pi by n. This part is called, anyone guess? This part is called, anyone guess?
omega.
This part is omega. Let's see. And another part is we are considering nk. What is that? Let's see. Let's see. So we call 2 pi by n is basically called the basic interval. Basic interval of the signal. 2 pi by n is the basic interval. And nk is time span. Nk is n into k is time span. Clear? So the problem we have faced here, that part is the phase. We are more comfortable with the magnitude part. But when in the formula you have with the phase part, then that will be problem for us to solve any kind of rigorous problem. So that's why we modified the formula. So just hold for the 1 minute. I just consider the second one. So what is that? So here in this PPT, we are associated with discussion with twiddle factor and 4-point and 8-point twiddle factor value to find 4-point and 8-point twiddle factor value. So let's see. This is the formula of modified version. What I am written in place of e to the power minus j 2 pi k into n by n. In place of that, we write down w k into n capital N. Similarly, e to the power j plus j 2 pi n into k by capital N. In place of that, we write down that is the w minus kn by capital N. So this part is the modified the DFT formula. We modified the DFT formula. Clear? Now let's see. This is the modified IDFT formula. Now let's see, talking about the twiddle factor. What is that? Wn is basically e to the power minus j 2 pi by n. Wn, which is the twiddle factor. Here I am not written w k into n by n. Here we just written Wn equals to e to the power minus j 2 pi by n. Whereas you know already the formula e to the power j omega or j theta, whatever, is basically cos theta. Silly mistake, sorry, extremely. This is cos theta plus j sin theta. E to the power j theta means cos theta plus j sin theta, where e to the power minus j theta is basically cos theta minus j sin theta. Are you agree with me? Yes or no? Please respond.
Yes.
Yes, sir.
So you know this formula part. And we already know that Wn means e to the power j 2 pi by n. Okay. This is called basically twiddle factor. And another name is there. Why we say this name, propose this name, we explain later on. We also say this twiddle factor is basically periodic phase rotation factor. This twiddle factor also named as periodic phase rotation factor. Why called this one is periodic phase rotation factor? Let's see in the next problem. So the problem here we found that find the value of twiddle factor W4. W4 means what about the value of N? Anyone?
4.
4. Clear. Okay, let's see. So that means we find out the value that is for 4-point DFT. I just talking about you one thing. Here we are finding the phase part. Here we are deal with the phase part. We are not talking about the magnitude. So first we try to solve the phase part. Later on we discuss the magnitude part also. So first we try to solve the phase part only. So in case of 4-point DFT, n equals to 4 you already mentioned. Then W4 equals to e to the power minus j 2 pi by 4 is the value. Yes or no?
Yes, sir.
Any other response, guys? Anyone? So can we write this line? W4 equals to e to the power minus j 2 pi by 4.
Yes.
Vikram, Shabonno is already okay. What about the other student?
So can you repeat this part once more?
Yes. Wait, what about the twiddle factor formula? So basis, I just go through the previous slide. This is your twiddle factor value. Wn equals to e to the power minus j 2 pi by n. Are you agree with me? Yes or no?
Yes, sir.
Okay. Now, in this problem, what I am written, find the value of twiddle factor W4. Clear? So W4 means 4-point DFT. We find out the 4-point DFT. We just find out the phase part only. What is that? N equals to 4. Yes or no? Shobhit?
Yes.
Yes.
Yes, sir.
Good. Now, can we write W4 equals to e to the power minus j 2 pi by 4?
Yes.
What about the other student, Akash?
Yes, sir.
Understand this part?
Yes. Yes.
Shayoni?
Yes, I got it.
Okay, Shayon,
Yes, sir. I got it.
Dev,
Got it, sir.
Animesh,
Yes, sir. Got it.
Aman,
Got it, sir.
Okay, so hopefully you understand this line. Okay, what about the next part? Now we just modified after the division. We can write down e to the power minus j pi by 2, and in if we consider cos and sine theta, this is cos. So please, extremely sorry, this is cos. So cos pi by 2 minus j pi by 2 sine j sine pi by 2. Yes or no?
Yes, sir. Yes, sir.
Okay. Now, if we calculate, you can use your calculator. You got this answer. Cos pi by 2 value is 0 and sine pi by value is 1. So 0 minus j, that is minus j. Got it. So hopefully in this part you understand. Now, what about this k into n. You remember? Twiddle factor in the modified formula, what we are written? W k into n by capital N. So that n, so small n, in case of DFT, small n vary from 0 to what? 0 to
3. Oh, n minus 1.
4.
0 to 3, n minus 1. So where n equals to 4 means that value from 0 to 3, yes or no?
Yes, sir.
Good. So that means we get 4 different value of twiddle factor. We get 4 different value of twiddle factor starting from W04, W14, W24 and W34. Are you agree with me? Yes or no?
Yes, sir.
So when we are talking about the phase, phase means there is an involvement of angle. There is an involvement of angle. So we are considering a circle. We are considering a circle. So if we have 4 points, so circle divided under 4 point means each angle is, or each point having some angle are involved. So that angle is 90 degree. Yes or no?
Yes, sir.
So suppose I asking you one question. Suppose here W in case of 8, so that means that W vary from how many value we get for W?
It is 0 to 7.
0 to 7. Good. 0 to 7. Clear. Thank you. Now, what about the angle of the each point? What about the angle?
45.
Others people, are you agree with Sabanna?
Yes, sir.
Good. So now, this angle is 90 degree. Now, what about the point we are here written? The first point we are considering W04. So always the first point are associated with this point. Always associate with this point. Always remember. Okay. In the formula, if minus sign is present in e to the power for DFT, basis on the DFT formula, this is e to the power minus j something is there. That means negative sign is present. Then we establish the point in clockwise turn. We establish the point in clockwise. So what about the first point we are considering? That part is this one. So clockwise means W, this point is value is basically W. Zero four. What about the next point is here? And that value is W14. Then this one is W24, this one is W34. And there, this part is there, which is basically repeated W44. This part is W54. This part is W64. So W74. This is W84. Clear, guys? Any doubt? Up to this, any doubt?
Sir, as the value of W4 is negative, that's why it is clockwise.
We are considering this is clockwise. We are considering this is clockwise. In case of DFT, in case of IDFT, there is a no negative sign present, yes or no? Means the plus sign is there. So W04 value always in the same position, but the W -14 is basically in anti-clockwise form. Anti-clockwise form. So we just remember one thing, that if negative sign is present, that means we are establish the point in clockwise, and the position of the first point always present over here, where basically W4 is present. Clear? Now you can see here, this is W04142434. So can you solve? Can you find out the value of W04142434? Because you already know the value, that is the theta we are considering as cos theta minus j sin theta. So basis on the formula, so can you find out the value of W041424 and 34? You just try yourself and again send me a WhatsApp. You try yourself and send me a WhatsApp quickly. Madam is sent. This is one line solution, so please do it quickly. Very first. We don't have a much time. We have only 4 minutes. So please do it now quickly and send me a WhatsApp. Anyone, please respond. Anyone? Quickly, guys, quickly, please respond. We don't have much time.
Sir, the answers are -j, -1 and k.
Please send me a WhatsApp. Send me a WhatsApp. Shabonno is already sent, no?
Yes, sir.
Yes, that part is fine. Like Shabunno, I want everyone to respond, please. সাবন্য ছেলেটা মানে রেসপন্ডিং, বাকিরা কেউ রেসপন্ড করছিস না তোরা। আজ এখানে অরুণাভ স্যারও কিন্তু রয়েছেন, আমার কাছেই রয়েছেন, স্যারকেই বলছি যে যত কম রেসপন্ডিং হবি তার তত কিন্তু লোকসান হবে। এখন কিন্তু এটা থার্ড ইয়ার উঠে গেছি, সেকেন্ড ইয়ার নয়। আমরা কিন্তু একদম ম্যান মার্কিং করবো। চাকদে ইন্ডিয়াতে মনে আছে ম্যান মার্কিং এর কনসেপ্ট, তো সেইভাবে কিন্তু আমরা ম্যান মার্কিং করবো। সো বি ভেরি কেয়ারফুল। Okay, let's see. I don't have time. It's 10:20 already. So basis on the formula, if we apply the value that cos 0 minus j sin 0, this is the value of 1. Sin 0 is 0 basically, so that's why cos 0 is 1. So basis on that, we get the value that 1 minus j minus 1 and j. The interesting part you can see over here, this is the positive axis, this is negative axis, this is also a negative axis, this is also a negative axis. So that's why you can see here, this is the value of 1, then minus j, this is minus 1, and this is j. The interesting part, W44 value, if we put the value of W44, this is also a 1. This is also a 1. So that's why I written over here. You can see here that W04 is similar value is W44. If you find W54, you can check yourself that value is minus j. W64, the value is minus 1. W74, the value is plus j. You can check yourself. This is your homework, isn't it? And you find up to W04 to W32.4. You just find out. This is your homework. I send you the question in your classroom. You please solve it, and accordingly you just upload the answer, isn't it? You just find out W04 to W32.4. So that is the reason we say this is periodic phase rotation factor. This is called twiddle factor, also called periodic phase rotation factor. Up to this, anyone having any doubt, please respond. Anyone having any doubt, please respond. Aparajita?
No, sir.
Nilakshi?
No, sir.
Prita?
No, sir.
Saurabh?
No, sir.
Sohini? Two Sohini is there.
No, sir.
Okay. Kaushal?
No, sir.
Arpon? Arpon response? Arpon? If you are present, please respond. Otherwise, I thought you are not present in my class. Arpon? Nigango? Anjuli?
Yes, sir.
Any doubt up to this?
No, sir.
Dev? Dev, response please.
No doubt, sir.
Okay, thank you. Shayan?
No, sir, no doubt.
Anirban?
No doubt, sir.
Bikram,
No doubt, sir.
thank you all for attending my class. Thank you.
Thank you, sir.
Thank you, sir.